Hello, New York City middle school teachers and administrators. This is Matt from Amplify, and in this video, I'm going to give you a basic introduction to Amplify Science for middle school. So let's get on into it. So Amplify Science is a partnership between the Lawrence Hall of Science out of UC Berkeley in California and Amplify, based here in Brooklyn. The Lawrence Hall of Science, LHS. LHS wrote Amplify Science, and LHS has been creating science curricula for pretty close to 50 years. And Amplify Science is the latest program out of LHS, and it's the only program designed for the new standards. And I'm going to talk about standards in a little bit here. Amplify, on the other hand, Amplify developed the technology upon which the program is served. You're going to see a bunch of that later as well. So what's the basic idea of Amplify Science? Well, in Amplify Science, in every unit of Amplify Science, that's about a month of content, in every unit, students take on the role of some type of scientist or engineer in order to investigate a real-world problem. And that real-world problem, it's introduced in the very first lesson, and it spans the entire unit. So as students are moving through lessons with a variety of different materials, and as they're figuring out this scientific phenomena, they're always applying it back to this real-world problem. I'll give you a couple of examples of that in a little bit here. But before we go there, let's just talk quickly about standards. Okay, so there are the Next Generation Science Standards, the NGSS. Those standards are in use by somewhere around 30 or so states in the US right now. The NGSS or close derivatives thereof. Those standards came out in 2013. New York, we have the New York State Science Learning Standards, the NYSSLS. What's the difference? How do we get there? Well, basically, the New York State Science Learning Standards, they take the NGSS, they make some meaningful changes in language to certain standards, and add a couple of new standards in. Or I should say, add a couple of the older standards into NGSS. Those are standards on circuits, density, a couple others. So you take the NGSS, tweak some standards, add a couple of ones in, and you get the NYSSLS. And that was adopted by New York in 2017. So Amplify Science was designed for NGSS. So how do we make sure we cover all of the New York standards? What we did is we took our national program, and then we wrote extra lessons. We call these New York City companion lessons. These make sure that New York City educators have access to great lessons that cover the extra topics that are on top of the NGSS. So that we have the Amplify Science New York City edition, so that you are covering all of your NYSSLS standards. Okay. To that point, how can you, teacher, administrator, how can you be sure and be confident that this program, which you're considering to put into your schools, into your middle schools, how do you know that it was developed well, that there's any evidence of efficacy? That's what I want to spend the next couple slides here. Let me give you a little bit of the backstory of Amplify Science. And so when the Lawrence Hall of Science set out to design a brand new program for these new standards, you've got to start somewhere. And so you start with a research-based approach. And that's exactly what they did. This approach, called Do, Talk, Read, Write, Visualize, you're going to see these are graphs from 3 different gold standard studies that were done on this approach. Really great data showing the efficacy of this approach. And if I could quickly summarize, what is Do, Talk, Read, Write, Visualize? What does that even mean? It says that all students are figuring out these science ideas through multiple modalities. Right? We like to say that they have multiple at-bats. So for each big science idea, they're going to be approaching that idea and again, trying to figure out that idea through doing hands-on activities, for example, talking, student-to-student discourse, argumentation, right? Group work, reading science texts, right? Marking up those texts, looking for evidence in those texts, writing scientific explanations, drawing models, and visualizing using media, using digital simulations. So each and every student is going to be able to interact with these ideas through multiple modalities. The study that you see on the screen right here, this was a study that was really focused on English language learners. You could think for an English language learner, this is a really powerful moment because instead of there being one way through which to learn this science, for example, a textbook, or for another example, just a kit, right? The English language learners and all students, because we know strategies that we use to support English language learners are able to support all types of learners. Though all of these students are able to interact with that one idea through doing, talking, reading, writing, visualizing. So it helps them to both figure out the science idea and also to articulate their understanding of the idea. Because a student might be able to really demonstrate understanding in a writing assignment, or it could be through an oral presentation, or through oral argumentation, or through drawing a model. So these next couple slides are just data from these efficacy studies. Again, this is the one that was based on English language learners. Here's one where we were gauging reading comprehension, vocabulary, science content knowledge. You see great gains in reading comprehension here. And finally, as Matt, travel across the country working with districts who have used and are using Amplify Science, one thing I hear over and over again is how noticeable student writing improves. So you start with this great research-based approach, and then the Lawrence Hall of Science wrote lessons, and we wrote units. And then you send those units to districts across the country so we could see if they actually work in real classrooms. So from 2014 to 2016, that's exactly what happened. An early version of the program was tested in real classrooms. We collected a ton of information, a ton of feedback, a ton of hard quantitative data during these field tests. We were then able to take all of that in and to rewrite the curriculum based on those field trials and on that data. So it was only that program, the rewritten program, that is Amplify Science, and that is what went out to customers. And Amplify Science has been used in classrooms across the United States, including here in the early grades, here in New York City, and in various other cities across the U.S. as well. However, that doesn't mean we're done. You're going to see Amplify Science. This is a dynamic program. This is not just we send it to you and then you talk to us later. No, we're always looking for ways to improve the program, make it more engaging for students, make it easier to use for teachers. So we are still collecting information about the program and about how teachers use it and how students use it. We're able to take this information and make some really meaningful updates and improvements to the program. What you're looking at here are assessment results for students for various units in Amplify Science. I should also mention that Amplify Science is being used in New York City today, here for middle school. There are about 11 schools who have been piloting the program, and we've again been getting some really fabulous feedback on how this is different, how are students responding to the program. So a couple of call outs to the simulations, to bringing planning time down. Really great feedback here. And lastly, so we research-based approach, field tested it, sent it, and then it's used across the country. One final thing, and you might have read about this in a couple of education publications recently, but the third the sort of reviewing group called Ed Reports. This is a completely separate organization. They just completed their first review of science materials, focusing on middle school. And across all the programs that they reviewed, only one program got the highest marks. what they like to call all green, right, across each of the different categories, including alignment to the new standards, usability. You'll see there are 3 different categories. The only program to score all greens was Amplify Science, something that we were really proud and thrilled when we got this rating. So this is very new news here. I'm sure you can check it out and read a little bit more about that. So that's the program that's going into your schools. Hopefully, hopefully. So let's talk a bit about the learning approach, a little bit more about our learning approach. So again, every unit, students take on the role, some type of scientist or engineer, to investigate a real-world problem. When I, Matt, had to learn about evaporation, freezing, when I had to learn about phase changes, how did I learn about it? Well, I memorized, right? That's what I did. You memorize the temperature, that water boils, that water freezes. I think we even did it in Fahrenheit, which, come on. So how does Amplify Science do that? You'll see it's going to be different. So in the Amplify Science unit called Phase Change, students take on the role of planetary chemists, and they are investigating the true story about how the Cassini spacecraft went to Saturn's moon Titan, took a picture of the surface of Titan, and detected on Titan's surface lakes of liquid methane. All right. Cassini then returned 2 years later to the same spot and took another picture of the same spot on Titan. And interestingly, those lakes of liquid methane had disappeared. They either froze solid or they evaporated. So it's through that real-world problem and through using a variety of materials, which I'm about to show you, that students are figuring out this phenomena and applying it back towards this problem of the disappearing lakes on Titan. So it's just one example of a unit. Another unit I like to kind of call out here is we have certain units that are really focused to engineering. And this one happens to be one of my favorites. So this unit, it's 10 lessons long, so 2 weeks or so of teaching. And so in this unit, students take on the role of civil engineers, and they're being brought in on a project where this city that happens to be sitting right next to a mountain, this city wants to reduce its levels of carbon emissions. And the way they're going about that is by redesigning the rooftops of this community. So again, even here, students are presented with a design problem. And what's great about these engineering internships is there's no one right answer that we're trying to get students to respond to. Rather, students are going to, with these design problems, create a design that best optimizes for competing design constraints. So for example, in this specific engineering internship, students have to balance the cost of their system. They have to balance the efficiency, how much can they reduce the carbon emissions, and they also have to balance the effects of their solution on the historic value of the city. Because as you'll see as you dig into this unit, students could put solar panels on the rooftops, or they can paint the rooftops white to increase the reflectivity off of the surface there. But if you just go and start painting the rooftops of all of the buildings in the city, well, some of these buildings are actually sort of protected and historic. And if you start painting the rooftops white, you could kind of destroy the historic value of the neighborhood. So they have to be very careful about which solution they choose for different rooftops. And sometimes it's better to not put white paint or solar panels. Ultimately, students will design and optimize they will come up with their own designs and then be able to propose and say why they think their design is the best and best sort of optimizes for those design constraints. So it's just 2 units for you. So students have a role and they've got a problem they're investigating. And then they're going to be collecting evidence from a variety of sources in order to help them figure out this scientific phenomena. So, how do students collect evidence? Well, first off, students have access here in middle school to science articles. And so you'll see that these are available both in print and digitally as well. the print. Here in New York City, you're going to see that every student gets a hardbound student edition. And there's one per grade level. So there's one in 6th grade, 7th grade, 8th grade. And those student editions compile all of the articles in all of the units at that grade level. So you've got a nice, durable student edition, hardbound. At the teacher's discretion, those texts, those exact same articles, are also available online. So if you wanted to get your students onto devices, you wanted to have them mark up the articles digitally, there are some really cool features, right? There's you can look up vocabulary terms, you can highlight, you can annotate directly on the article digitally. There's a great audio feature, so you can have a human voice read the article back to you. That is available, but totally optional. Whichever format you prefer, it's really meant to be a flexible implementation, right? Meeting a variety of different realities of how much technologies are in different schools, or just teachers' styles, right? Maybe you want to have less screen time and you want to have students really marking up the pages on paper. You can do that as well. To that point, I should also mention PDFs of all these articles are available on the Digital Teacher's Guide, which every teacher gets access to. So you can download those PDFs, print them out, and some teachers I know like to have students put pen to page. That's a great way to do it. You wouldn't do that in the print student edition, but you could totally download these, print them up, hand them out to students, and they can mark them up directly. So we have science texts, articles that students will use. That's one of the evidence sources. We also have hands-on materials and activities. Yeah, there are kits for every unit here in Amplify Science. So various lessons will call for the use of hands-on materials. That's yet another evidence source. You're going to see digital simulations. We try to make the use of simulations authentic to the way that scientists go about investigating scientific phenomena. So I'll give you a quick example. How do you investigate plate tectonics, right? Plate motion, through a hands-on activity? Well, there are some good ways to sort of model plate motion in a hands-on activity. Absolutely, you'll see those in the unit. But you know what? When it comes to seeing how plates move over the course of millions of years and in a variety of different ways, having access to a simulation where you can really it's not a video where you just hit play and watch it happen in front of you. No, you empower students with these simulations that have different variables, and students will be able to set these different variables and then get it going and start to collect some really meaningful evidence from their simulations. Every unit in Amplify Science Middle School has a simulation. You're really going to see how they complement the readings, how they complement the hands-on activities. All of these different materials really work together. Again, go back to that research-based approach that I mentioned before, doing, talking, reading, writing, visualize. You can see how that's now manifesting itself in the student-facing materials. Okay, what else do we have? Student-to-student discourse, right? Sometimes that aha moment happens when a student has to explain their ideas or explain their questions to their peers. And so you'll see in the lessons of Amplify Science, time for partner work, yes. Time for group work, absolutely. Time for whole class discussions and argumentation activities. It's written into the curriculum. It's a critical sense-making strategy is to get students talking like scientists. So you will see this in your lessons as well. And of course, assessments. Yes, there's a pre-unit, a mid-unit, and an end-of-unit assessments with multiple choice questions and short responses. That's all in there. If you can get students to take those assessments on a device, all those multiple choice get automatically scored for you, saving you some time. But then also you'll see that a lot of the magic in terms of assessment are in those formative assessments. Those students don't know they're being assessed assessments. Those moments where students are doing some activity, maybe it's a hands-on activity, maybe it's using a simulation, and you as a teacher have the right questions at your disposal to really help you elicit student understanding and growth and misconceptions in a given moment. all of those different types of assessments. That's baked into the program. You're going to see that in your lessons. I also like to mention that all student-facing materials, so that's the assessments, that is the articles, of course. One thing that I haven't shown you but is included in every unit is that the teacher also has inside of their kits, there are printed materials for building out a concept wall, right, like a vocabulary wall, posting key questions, posting key concepts that we sort of that we're able to understand and arrive at in the course of a unit. All of those printed materials that get posted onto the wall, all of that is available in Spanish as well. So we have that available. One last thing I should mention, I just remembered this, is that in the student editions, the hardbound print sort of compilations of all the readings for a given grade level, at the back of the student editions, there is a 10-language multilingual glossary. So the vocabulary, all of the vocabulary that appears in that grade is translated into 10 languages. I won't list all 10 of them, but you can go and be sure to go ahead and check that out as well. So students are using these materials. We're progressing through the lessons. Every lesson calls upon some different permutation of materials. And we're using these to really construct increasingly sophisticated understanding of the scientific phenomena that we are investigating. And that's it. That's the basic structure of every unit. Take on the role of some type of scientist or engineer to investigate a real-world problem. Collect evidence from multiple sources. Remember, think of that do, talk, read, write, visualize thing I mentioned before. And moving through lessons, developing increasingly sophisticated models and explanations of that scientific phenomena. You're going to see here in middle school, there's really a special moment. It's chapter 4 of any given unit. There's a great moment where we then conclude that main storyline, if you will, and students are then presented in chapter 4 with a brand new problem, something they hadn't seen over the course of this unit, and it's their opportunity to take everything that they've learned in the unit and apply it to this brand new problem. So be sure to look for that when you dig into the materials. Finally, I want to mention for teachers, you all get printed teacher's guides by default. So there are indeed teacher's guides in print for every unit. Also, there's access to digital teacher's guide, to a digital teacher's guide, and you can go on there as well. What you'll see, actually, I'll get there in a moment, but you're going to see that the content in the printed teacher's guide and the digital teacher's guide is the same. I should mention, the digital's teacher guide will make reference to simulations or videos, which are obviously not accessible through the print edition, so you do need to go to your digital teacher's guide to pull down the videos or the simulations or different projections and question prompts. But you can see what you can download when you jump into your digital teacher's guide. This is just the titles of the units across each of the grade levels, but the titles are pretty well give you a hint of the topics that are covered and the standards that are covered in each of these units. But yeah, this is custom for you guys here in New York City. Just to help us again visualize this, let's take a look at grade 7. If I kind of spin it and look at it horizontally instead of vertically, you could kind of think of the curriculum hierarchy. Okay, grade 7 is made up of X number of units. One unit, for example here, phase change. One unit is composed of 4 chapters, which are collections of lessons that you will progress through sequentially. I could see chapter 2 has 3 lessons within it, and the second lesson, lesson 2.2, that is composed of about 5 different activities. That lesson looks like it starts with a warm-up, then it gets to a hands-on activity. We use a sim, watch a video, and conclude with a discussion. And your teacher's guides lay this all out super clearly for you. So every activity has very clear step-by-step instructions. We even provide some model language if you want to use it. Every activity also, when it's appropriate, giving you the possible responses, like an answer key. And every lesson tells you how to set up the lesson, what to do in between classes. Maybe you set up stations and you've got to reset the stations between class periods. We'll even give you that level of preparation. You're going to see all of that in your digital teacher's guide. And in your print teacher's guide. I'll flip back and forth between these slides. So this is just a screenshot I took from the printed teacher's guide. You can see it's the exact same content as what's available in the digital teacher's guide. Same lesson, same activity, same instructions. But again, you do need to go to your digital teacher's guide to pull down the simulation, for example, or to be showing a movie. But you understand that as well. So let's capture everything that I've said. There are 3 types of units: a launch unit, which starts the year; core units, the majority of your units; and those engineering internships. Core units, for example, 16 lessons plus that pre, mid, and post unit assessment. All lessons here in middle school meant for 45-minute sessions. Each kit, remember I said every unit's got a box. Each materials kit is meant for one teacher with 5 classrooms of 40 students each. So you can say that's 200 students served in total per kit. I mentioned these student editions, hardbound durables that contain all of the readings at that grade level, right? So there are 3 in total. There's a 6th grade, a 7th grade, and an 8th grade one. Teachers, you have access to print and digital teacher's guides. And I should also mention, you also as a teacher have access to, the teacher, have access to digital student notebooks, which you can really help and should really help you and your students to develop their own student notebooks. So how does Amplify Science support notebooking? That's something you'll learn more about should you opt in the summer professional learning and training sessions, and something that we're really proud of and excited about. And then finally, as I mentioned at the top, we have special lessons, New York City companion lessons, which are really how we addressed and really make sure that very, very clearly address those extra standards that New York adopted in the NYSSLS that are otherwise not found in the NGSS. All right, so with that, I think that is my final slide here. I hope you dive into a unit and go and check out the program. So thank you so much, and I hope you enjoy learning more about Amplify Science in the months to come.